My name's Kevin. I'm a senior cloud security engineer at Netflix, and today I'm going to talk to you about security groups. Uh, Before we get started, who is familiar with and uses AWS in their day-to-day kind of security methodology? Great. Of those people, who deal with security groups on a day-to-day basis, or who knows what they are? Awesome. For those who don't, no worries. I'm going to give you a bit of a primer. So what are security groups? Essentially, security groups are just firewall rules by a different name. You can think of them in relatively the same context as you would any other firewall rule, restricting access from one application server to another on a networking level, right? So this provides us ingress and egress network filtering. It does this filtering by site range, by IP, by port, and it also has this idea of a group membership. So in your traditional firewall rule, these are standard kind of rules that you may apply to an individual instance. You say this IP, this static IP, or this range of IPs or network location can talk to me and have effective network communication. Security groups go one step further. And it's very important that we kind of talk about this because it's very unique to the way that AWS works and dynamic kind of infrastructure works as a whole. So group membership in the context of security groups is essentially this idea that for any given instance, any given cluster, you can have anywhere between 1 to 1,000 to 100,000 of these servers. And managing access by an individual IP doesn't really make sense, nor does it make sense to manage them by even a range of IPs. Group membership, or security groups as assigned to an individual instance, basically says that anyone within that role or within that group, as that group associated with them, is allowed to talk to me. And in this way, it facilitates this kind of dynamic access to be allowed on a network level. Security groups are also account and region specific. So these rules have to be managed depending on your application deployment on many different accounts and many different regions. So what are some limitations of security groups? So anyone familiar with AWS is that there's always a limitation. So AWS does this to protect themselves. They do it to protect their customers. And they do it to give you basically boundaries and limitations such that you don't end up affecting yourself long run. So for security groups, these are the default limitations for an AWS account if you went through and created it today. So you're limited to 500 groups, 50 rules, and 5 groups per interface. And I want to bring this up because it's important when we think about some of the later concepts, we'll talk about it, but all of these limitations are basically constraints to what we can do and how we manage our security group infrastructure and our security group deployment. So now you have a brief overview of what a security group is. It's a firewall rule. It's not very scary, just allowing very simple ingress and egress network connectivity between 2 different application servers or different instances. I want to talk to you a little bit about the history of security groups and our experience with them. So back when AWS was first deployed, they had this idea of a classic networking stack. And in classic, everything was very flat. So you can kind of think of classic as almost an internet, basically internet as itself, right? So every host was routable. Every host was generally available if it had connectivity. In classic networking for AWS, security groups only controlled ingress access. They didn't control egress access. Most access was allowed via this group membership mentality because we had lots of large different server farms scaling up and scaling down. And this has been deprecated. So if you spin up a new AWS account today, this is not the networking you are enabled. You may still have it if you're a legacy account, but for all intents and purposes, this has been deprecated by AWS, and they moved on to something called the VPC. So what is a VPC? So VPC is a networking kind of paradigm that you may be more familiar with if you're coming from a data center. This was basically a overlaid network on top of EC2 Classic, and they improved a lot of different things when they did this, right? So they went from this very flat networking architecture, openly routable to everything, and then went to a more conventional networking stack with dedicated subnets, routes, ACLs between those different subnets, and just general increase in network segmentation. Additionally, they also added egress filtering to the ingress filtering, allowing you to specify both inbound and outbound traffic to your individual instances. One of the most important things they added to the VPC networking stack is the ability to essentially analyze your network flows between any given instance. In EC2 Classic, we didn't have this ability. We were largely in the dark about traffic going in and out of our particular instances. VPC introduced this feature called VPC flow logs that it gives you net flow style ability to see the inbound and outbound traffic flows for any given instance. So we were in that deprecated state for a long time. And only just recently, probably about a year ago, did we undertake the migration to go from EC2 Classic to VPC. And as a cloud-first company that Netflix is, we had probably thousands of applications, hundreds of thousands of instances in this classic stack. And moving them to a new networking paradigm was a big challenge for us. It took us a lot of time, took a lot of engineering effort to move into this new paradigm from things generally being accessible to having to worry about subnets and IP space and routes. And on the infrastructure level, what we really wanted to do was abstract this away as much as possible from the developers. So from their point of view, they shouldn't really have to care this change is happening. They should be rightly focused on pushing new features and streaming awesome movies and TV shows. And during this process, we made several different compromises. So before the compromises, we kind of take a look at the constraints that we were facing, right? So EC2 Classic provided us no telemetry on which services were talking to which. Internally, we're a microservices company, so we had lots and lots of different services talking to lots and lots of other different services. This had grown organically. The dependency graph for those microservices was and still is very complex. In addition to that, we had a compressed schedule. So AWS was aggressively deprecating EC2 Classic and essentially gave us not necessarily a deadline, but a lot of incentives to move off of EC2 Classic as quickly as we could. So some of the constraints, or some of the compromises that we made, essentially we needed a way to bridge the gap between this very flat networking stack and our new VPC networks. This was provided via this idea of a classic link, basically a private interface that would span both the public EC2 Classic networking and our new internal VPC address space. And essentially what we did was we made those instances generally available to our VPC. Now, this was particularly tough from a security standpoint. Anytime we talk about security, we talk about least privilege, we talk about only allowing access to things that actually need access to. Unfortunately, due to the lack of insight in the complex dependency graph and all the other constraints I mentioned, it became very obvious that least privilege was not going to work for this migration process. So we decided to make a compromise to allow this access more generally during this migration period. We also made the compromise with engineering teams explicitly stating that new accounts, new AWS accounts, would have no implicit access to a given given services within those VPCs. And that was the one kind of security trade-off we were able to make during this migration process. So I want to talk a little bit about the current state. I always put these up in all of my slides because I think it's important for to how we think about our problems and how we think about how we solve them. At Netflix, we give a lot of freedom to developers, right? So they're pushing code, they own the stack, they own all parts of their application. And as a security team, we don't try to put in roadblocks or sign-offs or kind of processes that would inhibit them from deploying new code and pushing new features. And from a security infrastructure team, this means that a lot of the work we do is providing tooling infrastructure around what we call a kind of a paved path or the right way to do things. The idea there being that if you give someone the option of walking through the woods versus walking on a road, they're obviously going to, or hopefully choose walking on the road because it's much easier or much more incentivized to kind of go along with what's provided for them. And by doing that, we can instill and kind of bake in security best practices for them as they walk down this path. In addition to providing that path, providing the infrastructure, providing the tooling to make their lives easier from the onset, the other component of this kind of culture of freedom is to essentially ensure that we are constantly vigilant about people making mistakes. So if you kind of have the notion that people are always going to make mistakes, it makes sense that we should be building tooling and infrastructure and best practices to catch those as quickly as possible. And that's largely how we kind of think about our solutions. So for us in the security space, we think about those two things, the paved path and the best and the safeguarding against mistakes. The first step to doing that is this idea of security maturity. So within our infrastructure, within our application deployment process, we enforce these 3 security groups on every application. The first one is fairly straightforward. This is to allow access from basically humans, right? So the idea here is that your average developer doesn't care about this. They don't know what a VPN, what a NAT is, what a Bastion is, right? So we take care of that for them. We manage that security group. By default, that access is generally limited, and we have additional controls around how humans interact with those services. So we manage that for them, and that's on all of our different applications. The second one here is similar, right? So think about infrastructure. Generally, application developers just expect infrastructure to be there. So you think about metrics, health checks, et cetera. Again, all of that access is taken care of by us as a centralized team, and basically abstracts that away from developers having to care about that. So our deployment process ensures that those 2 groups are always placed so that developers don't really have to think about those 2 pieces of access to their application. And the third is essentially this idea that if we believe that application developers know best, they also know best about what applications need or which services need to talk to their service. And this third group is their application-specific group. So this is unique to their particular application and is controlled by the application owner. It is ultimately up to them who can talk to them, and so they are allowed to modify this as they see fit. This gives them the flexibility that, and basically the locality that we can assume that that specific group is controlling access to all of their different, to all the services that need to talk to them. And with these 3 things in mind, we can kind of start to make some assumptions about our environment where we wouldn't be able to necessarily do before. This kind of methodology also extends to technology-specific groups. So you think about all the different AWS technologies that exist, ELB, RDS, they all have different port requirements, they all have different perhaps access level requirements. And so we extend this kind of naming methodology to those technologies as well, and enforcing basically that the centralized managed ones have technology-specific rules, or technology-specific groups, as well as an application owner if they need access, or if they have an ELB, if they have an RDS, are again controlling access on application-specific basis for those technologies. In addition to that, we like to manage a lot of our stuff as code. So what that means is that it's fairly transparent for adding new things. We can basically have PRs into new rules. We can see who added which rule into our kind of managed security group state. And we can also enforce it. So we can basically say, is the infrastructure as we say it is, right? So we can periodically check what the current rules are for any given security group, and then put them back if something's drifted. This again goes along with this idea of like safeguard. Essentially, we'll let you modify rules more generally, but there are going to be certain situations where we say that is really not how it should be, and we're going to go ahead and place that back. In addition to this, we have many different accounts. We have over 100 different AWS accounts in at least 3 or 4 different regions in all those accounts. And managing it as a template saves us a lot of work when it comes to pushing out and making sure that these security groups are the same across accounts, regions, et cetera. So now that you have kind of a good background into how security groups are managed at Netflix and how we got to where we are today, I'm going to talk to you a little bit about an application called Grouper. And essentially what Grouper is that we got ourselves into a pretty bad state, right, with this migration. We are generally allowing access from vast swaths of our infrastructure, and we needed a way to tighten that down to obtain this idea of least privilege again. So Grouper essentially helps us do that by taking data about our environment, so metadata about what clusters are actively launched, right, and which security groups are associated with them. Once it has this kind of cluster information about the application itself and the security groups associated with it, basically the rules that it's allowing, it takes a look at the network flows for that particular application. Combining those two gives us basically recommendations around what should and should not be allowed. Here, one of the first steps we do is we target the ASG cluster. We grab the development unit, so this would be like the ASG, the application name, any of the security groups associated with it. And we query an application called Dredge. Dredge is a metadata collection system. Essentially, it collects the VPC full logs and ties the metadata from AWS to those full logs. So if you've ever taken a look, flow log or netflow is simply, say TCP, the bytes kind of sent, the source and dest, right? From a security perspective, that's not super useful. It's not even super useful from the perspective that these applications are changing all the time. An IP in AWS can move from one host to the other dynamically. Essentially, what Dredge does is to take and process that data in real time to determine who has that IP at any given time, and then allows us to make correct recommendations regarding those different traffic flows. So here we talk a little bit about making the ideal reality. And essentially what we do is within Grouper itself, we take those observed flows, we take this list of applications that are talking to each other, inbound and outbound. We say, what is the ideal security state of that, right? So if you see an application that, based on its observed flows, is only receiving data or is only receiving network communication on port 80 from a set of 3 or 4 clusters. But the security group rule, so the security rule for that particular cluster should only allow that port from those specific clusters. But, and then essentially we take that ideal state and compare it against reality, right? So from our perspective, that becomes a recommendation. Essentially we say that if a rule is too permissive, that means it has more ports or more access than it needs to, and it should be tightened down. If it's extraneous, right? So if it's not being used at all, that rule should be removed outright. And if it's, and it should essentially allow you to create the best possible group that you can, taking into account stuff like cross-region communication, the duplication of rules across events. So if a rule is in a managed rule, then we don't take it in consideration. It's a duplicate rule that's not necessarily needed anymore. And then we take these recommendations and we surface them to application owner. So we don't make any purposeful judgments. It's largely about creating insight to application owners. So allowing them to understand what applications are talking to them and which applications they are talking to, and allowing them to make appropriate decisions on those recommendations, right? So, and this is presented to them essentially as a health metric. So we have, application owners have this ability to see the health of their application. It includes things like jars that are deprecated that they need to upgrade, things that they're failing, so health checks that are failing in stale configurations. This is surfaced, this data, this configuration recommendation is surfaced alongside that so that they can see from high level what they can do to improve the overall health of their system relatively easily. And once they decide to take action, they are able to do that as part of this kind of health metric. So why do we do this? Well, we were in a state that was highly permissive. We needed a way to clamp down on this. We needed a way to do that without breaking existing applications. So you think about a lot of these things, very complex dependency graphs. We wanted to make sure that developers could roll this out as they saw fit, as they were continually improving their application, and empowering them to do that. It also provides us with this ability to basically clean up a lot of cruft. So if you ever try to manage security groups on a one-off basis, essentially what happens a lot is a developer will keep adding rules until things work. And they don't actually understand why things work, but it works now, so they're not going to touch it again. This leads to a lot of very overly permissive rules. It leads to a lot of unused rules that may have not worked for one reason or the other. And it leads to a lot of these different things that Grouper basically provides us the ability to clean up using this recommendation system. And again, it's very important to provide this backstop, this kind of check to help developers out when they have poorly thought out rules or rules that don't really make sense for their given application. So what are some challenges? So I mentioned briefly earlier that AWS has these idea of limits, right? So one of our big challenges to restricting access to be least privileged as possible for security groups and security rules is this limit of 50 different rules. So this limitation is very important to us essentially because you can only get so specific. So take this example here. This 50 rules applies to both ingress and egress rules. If you have, say, 50 services that need to talk to you, you want to be as specific as possible, you couldn't have more than that, right? So this limitation becomes very difficult for us to manage and is a large reason why we are still not able to get as specific as we want today. We're currently working with AWS on trying to help and fix some of those flexibility issues, but it's still a very big challenge for Grouper to deal with today. And essentially what it is it allows us to be best effort and to take this limit into consideration when we make our recommendations. Another big challenge for us is essentially this idea that if you're using network flows to derive rules, what happens if those network data is very infrequent? What happens when that network data hasn't been exercised in a very long time? So our ideal case here is that new applications know which services they need, right? So they can properly ingress the applications that need to talk to them, and there's no problem there. The recommendations will line up cleanly with what the developer has added, and that looks great. Problematic case is essentially where applications don't know which services need to talk to them, but basically they can have some downtime. They can have the ability to see what the errors are by looking at rejected network requests, and we go ahead and appropriately add those and create recommendations saying you need to add this service to your application. And that's not so bad. It may break some applications for a little bit of time. The catastrophic case I mentioned here is kind of what keeps me up at night. Essentially, this is the idea that new applications don't know which services they need access to and have very infrequent runtime dependencies. So the most common scenario that this kind of happens would be things like maybe you have a job that runs on a cron that's once a quarter. Maybe you have a cache that is always getting hit, and only when a cache misses do you fall back to a secondary service that may never happen or may happen very, very infrequently. And so those two kind of cases we don't have a good solution for. It's mostly around ensuring that we look over a long enough period, if possible, of network information to determine what the long-running dependencies may be. And it is currently something we're thinking very deeply about and trying to figure out if things like static analysis can help, if there's some other methodology that perhaps could surface these runtime dependencies before they actually get triggered. So the future state of Grouper is evolving. Some of the things we'd like to look into and would like to explore would be this idea of canarying security group changes. So if you've never heard of a canary before, it's essentially this idea of sending a little bit of traffic to a new configuration or a new piece of code and seeing what happens, right? So if you send a percentage, a low percentage, maybe 1% of the traffic for any given service, you want to see if something's failed. And we really want to try to extend this methodology to configuration changes like security groups, so that we don't break all the services unnecessarily. We'd also like to be able to roll back changes automatically. So in the event that a rule change was made that was problematic as detected by a drop in requests, a drop in successful requests, the ability to automatically take that back and reverse it would be really, really cool. And then the last thing we kind of want to think about is this idea of IP management. So today in security groups, you kind of manage IPs as a very spread out, a very disparate kind of system. Essentially, the string is spread out through all these security groups, and it's not a first-class citizen. We struggle with managing these kind of rules because they can change, and we don't have a good way of basically managing them centrally for all of our security groups across all of our different accounts. And that's something we really want to kind of explore. I want to call out a couple things that I've seen around. dmeter is a very interesting project out of Coinbase that manages your security groups for you. So essentially that idea of, that templating idea of having your template that's described to many different accounts and regions, dmeter will help you do that. And I also want to call out another open source Netflix project we have called RepoKit. Essentially, this idea of having or taking actually access requirements and deriving configurations off of them is what RepoKit does for IAM. So for AWS IAM, if you're not familiar, there's different permissions out to AWS's services. And what RepoKit does is to look to see which services you're actually using and then deriving a IAM policy based off of that so that you have the least possible number of services that you actually need. I want to throw up a couple other links. Check out our tech blog. We have lots of cool open source. Obviously, if you'd like to come out to California and hang out with us, that'd be awesome too. And that's really all I had for you guys.